All right, welcome to chapter 12 on sheet metal. Um, Here I have the second exercise from the chapter. Um, so you look at my feature tree, it should match what's in the book. And to verify that everything worked all right, we flatten the part, and sure enough, it flattens without any problem. So we'll go ahead and form it. Back at it, isometric view, and we'll save it. Now, that part was not quite as difficult for a lot of people. Um, so the purpose for this video is more to help with the dimensioning of the drawing for this part. So let's go to my drawing, and I'm going to bring in my part. Scroll down here, go to the flat pattern, and that's not really the orientation we want. Let's go ahead and rotate it 90, and it's a little small as well, so let's go ahead and no, we need sheet scale, so we'll size it once we place it on the drawing. So we'll place it, check mark there. Let's go ahead and edit the properties, change that scale to 1. That will make it a little bigger for us. And so, generally speaking, with sheet metal parts, you're going to see these notations here for the brakes on the brake lines. That's normal. That's perfectly okay that those are on the part. And the other things that we normally see are overall dimensions. Have an overall that way, this way. So I was too quick to click off of it. There we go. Place it like that. Now those are overall dimensions, and those are really important for allocating the right amount of sheet material. So with sheet metal in particular, we really want to see those two dimensions. Other important dimensions that the shop is going to need is we want a dimension this way that gives us the length of this side. And yeah, it's not fabulous that it crosses like this. We might end up bringing this one down to the bottom later after we get the rest of the dimensions on here so we can see what they look like. Next, we want to know from this edge, where is this brake line at? Because if we don't have a laser that can etch that line on there for us, and we don't have a notch to help the shop determine where that line's at, we have to give them a dimension of some kind. So we're going to start by clicking on that line. Then we're going to come down here to this corner. We're going to highlight. We're not going to click anything yet. We're going to highlight this line. We're going to right click, and this option here says find intersection. Now we come up here to this line, and what we're going to do is we're going to find where these two edges normally would meet, because that's what's called a virtual sharp. So that gives us our point from this edge to where this line would come to if this edge and this edge came out to meet it. Next, we do the same thing over here. This one's going to be on the inside of the part, which is normal because of this inside. And we just continue that around to give us all these edges. This is the part that is very difficult to avoid, to the point that I'm not sure how you would avoid it, because in order to go to the same point at these angles, they have to cross here. Now, I know I've said time and time again not to let them cross, and ideally speaking, we don't want them to cross, but in this case, it's an exception because there's no other way to dimension these sides without allowing them to cross. The other option would be to place the dimension on the part, but then we have a problem of all these dimensions on the part, and it becomes very cluttered to see what the part looks like. So we'll just continue on around. To get our other dimensions. And at that point, we don't need any more because this side and this side are the same. This side and this side are the same. So we don't need to have those as long as we understand that this is a symmetrical part. So next we come down here and we get the outside. And at that point, we don't need any more because this side and this side again are the same. This side and this side are the same. So next, what else do we need to have? Well, it would be nice to have this length. But here we run into the dilemma of how do we place this while keeping with all the rules? Well, we can't. So we're stuck with sacrificing one of the rules and placing it on the part or crossing a whole bunch of dimensions. And so what it boils down to is what is going to be the cleanest, most clear way to convey to the shop what this distance is. And I've chosen to place it right here on the part, away from the brake line, but not so far away that it's right in the middle and looks cluttered. So next we have this one. And this one is the same as this over here. And if you think about it, that makes sense. Because this side and this side, when it's formed, become this side. So it makes sense that the distance from here to here would be the same as from here to here. Then this side and this side are the same. So we only need one dimension for here, because it's going to be the same for here to here. And so therefore, we minimize the amount of confusion, clutter, and I guess you might say breaking the rules of dimensioning. And this dimension, where it's placed at with this one inside, is probably as clean as it's going to get, because if we brought it down, it would cross right through this one. So that's probably about as clean as we're going to get, and can't really make it any nicer looking. So that would be all the dimensions that we need for this flat pattern. And placing these virtual sharps here is a good place to use it. In fact, a lot of places to use it. But that particular style of corner is used in lots of places, and so therefore knowing how to dimension to that virtual sharp can be very valuable. So that concludes this short demonstration of how to dimension a sheet metal part. Thanks for watching.